Hello, my name is Rob Reynolds, and I'm going to show you how to complete the square to graph a circle. If a circle is given in standard form, we want to put it in standard graphing form. We're going to complete the square. So I think this is off of section 2.4, and it's question number 7 off of your MyMathLab if you're following along. Now, if the coefficients are a 1, this is kind of an easier problem. If the coefficients aren't 1, we'll have to factor out so that the leading coefficients are 1. But for this particular problem, I'm just going to combine the x terms, and I will also try to throw the y terms together. So y squared minus 2y plus some number. And I'm going to complete the square for both the green and the red. And I'm going to throw the 34 on the other side. And then I'll add two numbers again. So whatever I'm adding to the left side, I'll have to add to the right side. And whatever I add to this left side over here in blue, I'll have to add to this side because it's an equation. And the equation states whatever I do to one side, I'll have to do to the other side. All right, so to complete the square, we're going to take half of the middle term. In this case, half of 2 is 1. 1 will square it. Now, if you had a factor out here that you had factored out, you have to distribute that. But in this case, again, it's a little bit easier because all I have to do is add 1 to both sides. So over here, this says take half of negative 2 and square it, which is also a 1. Not very interesting. I should probably work a different problem for you. Factors of 1 that add up to 2 are 1 and 1. Y minus 1, all of this factors right here, all of this factors to y minus 1 quantity squared, and this will equal 36, which is pretty nice because then I know that the radius is 6, and over here I know that the center is the opposite of the x and the opposite of the y, so negative 1, 1. Because the general form of an equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So if r squared equals 36, then r equals 6. So to graph this circle, I'm going to start at negative 1, 1. There's the center of the circle, and I will just move 6 to the right, 6 up, 6 down, and 6 to the left, and graph that circle as best I can. 6 in every direction. So using MyMathLab, it looks like this might be a little bit better representation. There is a second part to this question, and it says find the intercepts of this graph. So the intercepts, looks like there's going to be at least 2 x-intercepts here and here, and 2 y-intercepts. And the y-intercepts can be found by letting x be 0. So I probably don't want to use this equation. It might be easier to go back and use this equation to solve. So let's go ahead and see if we can't use the equation that we found. And to find a y-intercept, I'm going to let x be 0. So if you let x be 0 right here, I'll get 0 plus 1, which is 1 squared. So 1 plus y minus 1 quantity squared should equal 36. Let's FOIL this out. Remember, you cannot distribute this, but we can square the first twice the product, square the last. We'll set this equal to 0. See, I've got 2 on the left. I'll subtract off 36. It's minus 34. And since I can't find factors of 34, I'll probably resort back to the quadratic formula. So x is equal to negative b, the opposite of this, plus or minus the square root of b squared minus 4 times a, which is a 1, and c, which negative 34 all divided by 2a. So I believe 4 minus 4 times negative 34 is about 140, which we could simplify the square root of 140 to 2 plus or minus the square root of, I think, 4, because the last two digits divide by 4. So 140 divided by 4 is 35, which I don't believe we can break that down into a perfect square again. All I have is 5 and 7. So this is really 2 plus or minus 2 squared root of 35 divided by 2. And I'm not going to cancel part of a sum, but I'll cancel both sums. So my final answer is 1 plus or minus the square root of 35. And the plus or minus gives me the two solutions that we thought that there was for the y-intercept. I'm going to repeat this process then for the x-intercepts. So going back to my original equation, let's see, before I found the y-intercept, I'm letting x be 0. Now I want to find the x-intercepts, and to do that I'm going to let y be 0. So I'll leave this alone. In fact, let's just FOIL this out. Don't distribute, but square the first, twice the product, square the last. This is a 0. 0 minus 1 is negative 1, but it's squared. So positive 1 is equal to 36. So it looks similar. But I believe this sign has changed. So we can run through it again. So x is equal to negative b. This time this is a negative 2 plus or minus the square root of b squared minus 4 times a times c. Looks like everything's going to stay the same except for positive 2 that I had before. Or it looks like it reduced to a 1. That positive 2 reduced. So instead of a positive 1, it looks like I'm going to have a negative 1. Plus or minus the square root of, and it looks like it's just going to be the same thing, 35. And I'll call that my x-intercepts. I hope that was helpful.